When discussing power in terms of electrical design, we are not really discussing a power system like we would a lighting system. Instead, the power workflow consists of coordinating with the other members of the design team to ensure that each component that needs power receives power. However, there is still an aspect of the distribution system that must be designed. When designing an electrical power distribution system in Revit, you will typically use the same general process. First, you need to add electrical equipment, such as switchgear, transformers, and panel boards. Then place electrical fixtures. These include devices such as receptacles, junction boxes, and other power devices. You can actually place fixtures or equipment first. The order is not too important. Next, you can define a circuit. After that, you can wire the circuit either automatically or manually using the tools in Revit. Once you have circuited the electrical devices, you can move on to the mechanical equipment and any other power loads. Essentially, you just need to coordinate with the other members of the design team and make sure that each component that needs power is assigned to the proper circuit and is receiving power. Once circuits have been defined and connected to a panel, you can create panel schedules. This is a high-level overview of the typical power workflow. Let's discuss some of these steps in a little more detail. You may be wondering why we should create circuits in Revit. Why not just wire the devices together? Circuits connect similar electrical components to form an electrical system. When circuits are created for a power system, only compatible devices can be connected. All devices in a circuit must specify the same distribution system. In other words, they must have the same voltage and number of poles. Then Revit will automatically calculate wire sizes for power circuits. Revit calculates the wire sizes for power circuits based on the size specified for circuit protection, voltage drop calculation, and correction factor. Wire sizes are automatically sized to maintain a voltage drop of less than 3% for branch circuits and 2% for feeder circuits at the outlet furthest from the source. That is, the circuit load determines the overcurrent protection required, which, when specified, then determines the wire sizes required for hot conductors, neutral conductors, and ground conductors. If needed, there are ways to adjust the wire sizes.